This is lesson 3.5, systems with three variables. So remember, a system of equations is more than one equation, and this one has three variables. So we're going to solve it very similarly to how we would have solved systems with only two variables, but it just takes a few more steps. So to start things off, I'm going to pick two equations. Let's go ahead and number these 1, 2, and 3. I want to look for one that I can easily cancel out the variable. I see that I already have 2x and 2x, so I'm going to take equation 2, which is 2x minus y minus 2z equals 5. And then I'm going to take equation 3, but I'm going to multiply it by a negative number. So I'm going to do a negative. So I'll have a negative 2x minus 2y plus z equals negative 4. Remember, I multiplied this whole entire thing here by negative. Then I add straight down. 2x minus 2x is 0x. Negative y minus 2y is negative 3y. Negative 2z plus z is negative z. And 5 minus 4 is 1. Now what I want to do, now that I have a y and a z, I want to use another equation, cancel out the x, and create another equation that has just a y and a z. So looking up here, I want to cancel out my x so I can multiply my number 1 equation by negative 2 and add it to my number 2 equation. So my number 1 equation multiplied by negative 2 would be negative 2x plus 4y minus 6z equals negative 24. Then I'll add my second equation, which is 2x minus y minus 2z equals 5. And we'll add those straight down. Negative 2x plus 2x is 0x. 4y minus y is 3y. Negative 6z minus 2z is negative 8z. And negative 24 plus 5 is going to be a negative 19. Now we have two equations with two variables. Looks very nice. We have a negative 3y and a 3y. So I'll just move this equation over. 3y minus 8z equals negative 19. We can add those straight down, and now our y's will cancel out. Negative z minus 8 is negative 9z. 1 minus 19 is negative 18. We'll divide both sides by negative 9 and get z equals a positive 2. Now that we know what z equals, we can take that and plug it into one of our other equations. We'll want to plug it into one of the ones that have two variables, so y and z, so we can solve for y. 3y minus 8 times 2 equals negative 19. 3y minus 16 equals negative 19. We'll add 16 to both sides. 3y equals negative 19 plus 16 is negative 3. So y equals negative 1. I'm going to go ahead and erase some of this work here. And so now we have z and we have y. So I'm going to pick one of my original equations, and I want to plug in my y and my z to figure out what my x is. So x minus 2, my y is negative 1 times negative 1, plus 3, my z is 2, so times 2, equals 12. Now we can solve that out. X, negative 2 times negative 1 will be a positive 2. 3 times 2 is 6, so 2 plus 6 equals 12. X plus 8 equals 12, so x equals 4. We now will write our answer as an ordered triple. We do alphabetical order, x, y, z, so that will be 4, comma, negative 1, comma, negative 2. And we just found three numbers that when plugged into each one of those equations makes a true statement. Now the first way we did it was with elimination. We can also do it using substitution. If I look at a system such as this, I see that my second equation, it would be pretty easy to solve for x. If I did that, I would have x equals negative 5y plus 9. And now I can take that x and plug it into one of my other equations. I could go ahead and let's plug it into my top equation. So it says 2x plus 3y minus 2z equals negative 1. So what I'm going to do is plug in that value for x instead. 2 times negative 5y plus 9, there's our substitution, plus 3y minus 2z equals negative 1. I'll distribute that 2, so I'll get a negative 10y plus 18 plus 3y minus 2z equals negative 1. Continue solving it out. Negative 10y plus 3y will be negative 7y plus 18 minus 2z equals negative 1. And then we will get negative 2y minus 2z equals negative 19. Now with this equation, there's really not much that I can do right now, but knowing what x equals, I see that I can plug it into this top equation, or this bottom equation, to make the bottom equation have only a y and a z. I'm going to erase some work and then get started. So now I'm going to plug in my new equation for x into the third equation down on the bottom. So 4z minus 5 times, instead of x, negative 5y plus 9 equals 4. So we'll distribute that negative 5, 4z, negative 5 times negative 5 is positive 25y, negative 5 times 9 is negative 45 equals 4. We'll add 45 to each side, and we get 4z plus 25y equals 49. I'm going to rewrite it to look like my bottom equation here with the y in front and the z in the back. So I'll get 25y plus 4z equals 49. Now I have two equations that can add up to eliminate a variable. It looks like if I multiply the bottom one by 2, I will have a positive 4z and a negative 4z. So let's go ahead and do that. We have 25y plus 4z equals 49. And then we have negative 14y minus 4z equals negative 38. Again, we multiplied everything by 2. We'll add straight down. We get 25 minus 14, that is 11y. 4z minus 4z is 0, equals 11. So y equals 1. Now we can take that and plug it into one of our previous equations. Again, I'm going to erase some of my work. So I know that x equals negative 5y plus 9, and I know what y equals, so I'll plug that in. X, oops, too thick, sorry, equals negative 5 times 1 plus 9. So x equals negative 5 plus 9, so x equals 4. Now I will go up to one of my even previous equations, maybe the first one, and plug in my x value and my y value in order to solve for z. So 2 times x, which we know is 4, plus 3 times y, which we know is 1, minus 2z equals negative 1. 8 plus 3 minus 2z equals negative 1. 11 minus 2z equals negative 1. We'll subtract 11 from each side. Negative 2z equals negative 12. Then divide by negative 2 and we get z equals 6. We will write our final answer as an ordered pair, x, y, z, ordered triple, 4, 1, 6. And that is a solution that plugs into each equation to make it true. Joke of the day, what do you call it when Batman skips church? Christian Bale.